Welcome back, everyone, to AI History of Western Philosophy. Today, we're embarking on, well, quite an intellectual adventure, I think. We're diving deep into one of the most persistent, profound, and frankly, pretty mind-bending questions humanity has ever grappled with. What is reality truly made of? Is it, endlessly smooth, like a continuous tapestry? Or does it actually pixelate at some fundamental, irreducible level?
We're going to take this sweeping journey, starting way back in ancient Greece and bring it right up to modern computing. We'll explore two really radical and maybe surprisingly interconnected ideas that try to answer just that.
Before we jump right in, just a quick note for everyone listening. AI-generated content, and specifically this podcast, AI History of Western Philosophy, well, it confabulates. It can present ideas as fact. And though our subject here is philosophy, we ourselves are not philosophers. The mission of AI History of Western Philosophy, beyond, pointing you towards the original sources, is really to experiment with philosophy as material and hopefully generate some new possibilities for thought. Absolutely. That's a really important point to keep in mind as we go. Okay, so let's start to really unpack this. Our mission today, as we see it, is to illuminate these fascinating parallels, but also the crucial differences between two really compelling frameworks. On one hand, we have ancient atomism, the ideas from Leucippus and Democritus. And on the other, the very modern simulation hypothesis. We'll trace their intellectual lineage, where these ideas came from. We'll dissect their core analogies. How similar are they really? And we'll even uncover how critiques that are literally centuries old still have a lot of potent force against these contemporary ideas. As always, our goal is to distill the most important nuggets of knowledge, drawing from our sources naturally. We want to help you become truly well-informed on this captivating topic, but, without feeling completely overwhelmed. So get ready for some genuine moments of hopefully philosophical clarity, some aha moments, perhaps.
Yeah, and what's truly fascinating here, I think, and what will probably jump out at you pretty quickly, is how both the ancient thinkers and the modern ones are grappling with the exact same fundamental tension. It's this dichotomy, this split between a continuous reality and a discrete one made of bits. These aren't just, historical curiosities or some kind of idle musings. They're actually sophisticated ontological frameworks, theories about the fundamental nature of being, really. And they were designed specifically to resolve these deep paradoxes about being itself, about motion, about our very perception of the world. Both approaches, ultimately, they posit a finite kind of granular resolution to the universe. By comparing them like this, we're essentially taking a shortcut, in a way, to understanding millennia of human thought on that huge question. What's truly real?
Okay, segment one then. Let's talk about the world in particles, the atomist philosophy of Leucippus and Democritus. To really appreciate how revolutionary atomism was, we first need to set the historical stage a bit. We need to understand the formidable intellectual giant it was, courageously challenging. I'm talking about the Eleatic school, and most prominently, Parmenides. Now, he was a philosopher who, just through pure abstract reasoning, like thinking things through without relying on what his senses told him, he came to this profoundly radical conclusion. He concluded that reality, or being as he called it, must be a single, eternal, unchanging, and utterly indivisible whole, one solid block. Now, that sounds pretty solid in itself, right? A unified, static reality. Seems almost logical at first glance.
Yeah, but if we connect this to the bigger picture, Parmenides' most radical and honestly most counterintuitive claim was that what is not, the concept of nothingness, the void, it simply cannot exist. Mm-hmm. His reasoning was, quite elegant in its simplicity. He said, look, to speak of nothing is to speak of something that is not. And that which is not cannot be. It's a contradiction. Therefore, the void is an impossibility, logically impossible. And, okay, if there's no empty space, no void, then motion and change become equally impossible. Think about it. Everything would just be one single contiguous block. There'd be nowhere for anything to move into. So this meant that the multiplicity, the diversity, the constant flux we perceive with our senses, the world of change and movement all around us, it must, by pure logical necessity, be an illusion. He effectively said, your senses are lying to you. True reality is immutable, unchanging. And this just raises this huge question for us, doesn't it? How do you even begin to explain the world as we actually experience it if fundamental change, motion, and multiplicity aren't actually real? It's a truly baffling starting point for trying to understand reality.
Absolutely baffling. And Parmenides' brilliant student, Zeno of Eleatic, he took this audacious line of reasoning even further. He crafted this series of paradoxes that honestly, even today, they can still make our heads spin. Like, think about the dichotomy paradox. A runner, right, can never actually reach a goal. Why? Because they must first cover half the distance. Okay, fine. But then they have to cover half of the remaining distance, and then half of that remaining distance, so on ad infinitum, forever. You'd always have this infinite number of smaller and smaller tasks to complete before you could ever reach the finish line, which seems impossible. Or the maybe even more famous one, Achilles and the tortoise. If the swift Achilles gives the slower tortoise even a small head start, Zeno argued, he can never actually catch it, because by the time Achilles reaches the point where the tortoise has already moved on to a new spot, however small the distance. Both of these paradoxes, they really hinge on this idea of the infinite divisibility of space and time, that you can always divide it further. So what does this all mean for Zeno? Well, he argued that motion itself is incoherent. It's logically impossible if reality is infinitely divisible, because it would require completing an infinite number of tasks in a finite amount of time, which is just, well, a logical impossibility. It's like a brilliant mind trap designed to prove that our everyday experience of movement must be fundamentally flawed.
Exactly. And the profound genius, then, of Leucippus and Democritus, who are generally seen as the founders of atomism, wasn't just to reject the Eleatic's conclusions outright. That would be too simple. Instead, their brilliance really lay in this sophisticated synthesis. They blended Parmenidean thought with the undeniable evidence of our senses. They actually agreed with Parmenides on the criteria for ultimate reality. They accepted that what is must be eternal, solid, unchangeable, and physically indivisible. Okay. But, and this is the key move, instead of one single giant what is, they pluralized it. They posited an infinite number of microscopic what is, each one conforming to Parmenides' strict description. These, of course, were the atoms. So in their view, each individual atom was basically like a tiny, indestructible Parmenidean universe all by itself. But crucially, there were countless numbers of them. This was just a monumental conceptual shift.
It really was. And this brings us to a truly pivotal moment in their whole philosophy, a point where it gets incredibly intriguing, I think. To explain the world of appearance, the undeniable change, the constant motion that Parmenides had just dismissed as illusion. The atomists made their most audacious, their most counterintuitive move. They granted ontological status, meaning they asserted the fundamental existence and reality to what is not, to nothingness. They essentially reified this nothingness, gave it concrete philosophical standing, and they called it the void.
A void, yeah.
By accepting the Parmenidean description of being, eternal, solid, indivisible, but applying it to a plurality of micro-objects, moving in a newly existent void, they brilliantly reconciled permanence with the undeniable everyday evidence of change and multiplicity. It wasn't just a philosophical debate tactic. It was a profound logical solution they were offering. They basically solved the Eleatic dilemma by saying, okay, empty space, nothingness does exist, something Parmenides had vehemently denied as impossible. And this conceptual maneuver, this acceptance of the void, truly opened up the possibility for a coherent, materialist explanation of the cosmos we see. It's quite the philosophical sleight of hand.
It really is. And the atomist system, at its core, is elegantly built upon just these two fundamental principles, atoms and the void. That's it. The atoms, right, so the term comes from the Greek atomos, which means uncuttable or indivisible. These are the plausitive, the solid constituents of reality. They aren't just small. They are physically indivisible. They represent the absolute ultimate limit of any material division. And these atoms are eternal. They were never created. They can't be destroyed. They possess this inherent permanence. The atomists also posited an infinite number of these particles. They argued there was, quote, no more reason for them to have one particular shape or size than another, hence their infinite variety. And they're perfectly solid, perfectly hard. They possess only primary quantitative properties, things you can objectively measure, their precise shape, their size, and their arrangement and position relative to one another. Democritus vividly described these as rhythm, that's shape-touching, that's arrangement and turning, that's position. And he emphasized that all the qualitative differences we perceive, like color or taste, they arise purely from these quantitative features.
And then, in stark contrast, you have the void, the negative principle, but just as crucial to their whole system. It's the utterly empty space between the atoms and separating the atoms. In a direct sort of head-on challenge to Parmenides, the atomists boldly argued that this what is not, this nothingness, exists just as surely, just as fundamentally as what is as the atoms. Its existence is a logical necessity, they argued, for motion to even happen. If things move, there must be empty space for them to move into. It's common sense, almost.
Seems obvious to us, but revolutionary then.
Exactly. The void is infinite in extent, allowing for endless atomic travel, and it's entirely passive. It offers no resistance whatsoever to the atoms as they just ceaselessly move and collide within it. It was this really radical reification of nothingness that truly allowed their system to explain the dynamic, changing, diverse world we perceive, freeing it from Parmenides' static, unchanging, monistic prison.
And from these two fundamental principles, atoms and the void, a purely mechanistic and thoroughly deterministic cosmos emerges. That's the outcome. Every single phenomenon, I mean, everything from the grand formation of entire worlds down to the most subtle nuances of human thought and sensation. It's all understood as a direct, necessary result of the unceasing motion of atoms colliding, rebounding, and tangling in the void. That's all there is. There are no ultimate goals in this universe, no inherent purposes, no divine interventions guiding this cosmic dance. Causality is reduced purely to the material interactions of bodies bumping into each other. This worldview is probably best encapsulated in that soul-surviving fragment from Leucippus, which is just so powerful. Nothing happens at random, but everything for a reason and by necessity. That statement just lays bare the strict determinism right at the heart of their philosophy. And it does raise that important question, one that echoes down through the centuries, really. If everything happens purely by necessity, driven by atomic collisions, well, how does that make you feel about the concept of free will? Where does human agency even fit into a world that's governed by this unyielding atomic causation?
Yeah, that concept of absolute necessity, it can feel quite unsettling, can't it? And it's fascinating to consider just how deeply it permeated their entire cosmic vision. Even something as grand and, seemingly purposeful as the creation of our world, our cosmos, is explained as just an automatic, inevitable consequence of these atomic mechanics. You have to imagine this vast collection of atoms just endlessly swirling and moving through the infinite void. Eventually, some fall into a vortex, a great cosmic whirl, and this motion just naturally sorts them by size and shape. The heavier or more entangled atoms, they gather at the center to form dense celestial bodies, planets, while the lighter ones get flung outwards to form the atmosphere, the stars. It's all just a purely natural self-organizing process, no designer needed.
Exactly. Mechanical.
And because the atoms in the void are infinite, the atomists logically concluded there must be innumerable other worlds out there, constantly forming, constantly decaying, each governed by the exact same mechanical laws. And this is where it gets particularly striking. I think it's basically a multiverse, ancient style.
Yeah.
Driven purely by mechanical necessity and the chance encounters of atoms, not by some divine design or grand cosmic purpose. What a profound implication for the nature of existence itself.
Perhaps, though, the most philosophically sophisticated and certainly the most enduring aspect of Democritus's atomism is his really revolutionary theory of perception and the nature of qualities. He drew this sharp fundamental distinction between objective reality, what's really out there, and our subjective experience of it. He famously stated, "By convention sweet is sweet, by convention bitter is bitter, by convention hot is hot, by convention cold is cold, by convention color is color." But in reality, he said, there are atoms and the void. That's it. So for him, the world truly, objectively, is just atoms with their primary qualities: shape, size, arrangement. Secondary qualities, the colors we see, the tastes we experience, sounds we hear, temperatures we feel. These do not exist as inherent properties within the atoms themselves. No red atoms, no sweet atoms. Instead, they're entirely emergent effects. They're subjective sensations that arise when atoms interact with our sense organs. For instance, sweetness, Democritus theorized, might come from smooth, rounded atoms passing over the tongue. Pleasant. Whereas bitterness could be caused by sharp, jagged atoms that, sort of tear the tongue.
Unpleasant. Vision, he believed, was due to objects constantly shedding these thin films of atoms called idola, which then flew across the void and impressed themselves upon the atoms of the eye. It's a truly ingenious mechanistic explanation for the apparent richness of our sensory world, even if it kind of relegates that richness to a realm of mere appearance or convention.
That is a truly radical idea. Let's pause and really unpack this one, because its implications, they just reverberate through philosophy right up to today. This model isn't just some ancient materialist theory. It's arguably the first clear formulation of what modern philosophers of mind now call the explanatory gap, or sometimes the hard problem of consciousness. How do you get mind from matter?
Exactly. The hard problem.
Democritus posits this purely quantitative mechanistic reality atoms and void somehow giving rise to a qualitatively rich perceived reality, colors, tastes, sounds. But then he declares these qualities exist only by convention. The Greek word was nomo. They aren't fundamentally fundamentally real in the same way atoms are. Now, he doesn't fully explain how the quantitative atomic collisions actually become the qualitative experience of, say, seeing red or tasting honey. He just asserts that it happens, and that the resulting qualities are not part of the fundamental furniture of the world. They're secondary. This deep ontological divorce, the split, it relegates our subjective experience to a kind of secondary, less real status. It implies that the vibrant, colorful, tasting, smelling world that we intimately experience every single moment is, at its core, an illusion. Just a mere effect of tiny, colorless, tasteless particles bumping into each other in the dark void. I mean, consider the sheer audacity for Democritus to posit that this vivid sensory world is, at bottom, a subjective overlay on an utterly mechanical, colorless, silent reality. This was a profound shift in how we understand our own place within the cosmos.
And what's truly fascinating here, really a testament to the enduring nature of these philosophical problems, is that Aristotle, who was one of atomism's most formidable critics, he recognized this exact challenge very early on. He critiqued atomism precisely for its inability to properly account for the reality of qualities. He argued, quite persuasively, that reducing things like color and taste to mere atomic shapes seemed to explain them away rather than genuinely explain them. It felt like a dismissal. For Aristotle, qualities were real, inherent aspects of a substance, not just illusions generated by shape. And this ancient critique, astonishingly, remains right at the heart of debates about consciousness today. We're still grappling with precisely how subjective experience, our inner qualia, arises from objective physical processes in the brain. And this naturally raises an important question for us to consider, right? If our vivid experience world is just a convention, a secondary internal effect, well, how much can we truly trust our senses? How reliable are they as a guide to what is fundamentally real about the universe? It forces a kind of profound skepticism about perception itself.
Okay, let's pivot now. From the ancient dust motes of Democritus, let's fast forward a remarkable 2.5 millennia, and we encounter a modern echo of these fundamental questions, though this time it's dressed in digital clothing. I'm talking about Nick Bostrom's simulation argument. It's a really compelling thought experiment, deeply rooted in our rapidly advancing technological capabilities. Now, Bostrom doesn't definitively claim that we are in a simulation. That's a common misconception. Rather, he presents this probabilistic trilemma. He contends that at least one of 3 interconnected propositions must, almost certainly, be true.
Right, let's break down this powerful trilemma in detail because the logic is quite neat. The 3 propositions are, first, the fraction of human-level civilizations that actually reach a post-human stage, meaning they develop the truly vast computational capacity needed for high-fidelity ancestor simulations, is very close to 0. So maybe technological limitations or maybe self-destruction prevents nearly all civilizations from ever getting that far. That's possibility 1. Second, the fraction of those post-human civilizations that are actually interested in running such detailed ancestor simulations is also very close to 0. Maybe, advanced beings find them ethically dubious or perhaps just boring or maybe computationally way too expensive, even for them. That's possibility 2. And the third proposition is this. The fraction of all observers with our kind of experiences who are living in a simulation is very close to 1. Now, the argument's force really comes from probability theory. If the first 2 propositions are false, meaning it is technologically feasible and advanced beings are interested, then it implies that a truly vast number of ancestor simulations will eventually be created.
And because each such advanced civilization could potentially run a huge number of these simulations, the total number of simulated conscious beings living inside these ancestor simulations would eventually vastly, perhaps exponentially, outnumber the real biological observers in the original base reality. So applying a principle of indifference, which basically says we, as observers, have no special reason right now to assume we are among the rare real ones rather than the vastly more numerous simulated ones, the statistical probability suggests we are almost certainly simulated. Now, it really hinges on a few key assumptions. The technological feasibility of creating genuinely conscious, high-fidelity simulations, the likely motivations of future beings, and crucially, the validity of applying this kind of probabilistic reasoning to our own existence. It's a statistical gamble, really, but with profound stakes.
That is quite a lot to wrap your head around, isn't it? And it really prompts us to ask, okay, what does this all mean for our fundamental understanding of ourselves, of consciousness? The philosophical linchpin, the absolute prerequisite for the entire simulation hypothesis to even get off the ground, is something called substrate independence. Have you heard of this?
Crucial concept, yeah.
It's the idea that consciousness isn't intrinsically tied to a specific physical medium, like our carbon-based brains or our biological neurons. Instead, it posits that consciousness is an emergent property of informational and computational structures. It's about the pattern, the information processing. It doesn't matter, according to this view, whether that pattern is instantiated in silicon chips, biological wetware, or maybe some entirely different exotic matter we haven't even conceived of yet. If the right functional organization and complex information processing are present, the argument goes, then consciousness will genuinely arise. It's a really powerful and central assumption.
Precisely. And this assumption of substrate independence, it directly engages with, and you could argue, it actually presupposes a solution to what philosophers call the hard problem of consciousness. That stubborn puzzle we mentioned earlier. How do purely physical processes like neurons firing or bits flipping in a computer give rise to subjective qualitative experiences, our qualia, the feeling of red, the taste of chocolate? The simulation hypothesis requires that a simulated being's qualia, the actual felt experience of redness or pain or joy, would be genuinely comparable, maybe even equivalent, to that of a biological being. Without this crucial equivalence, simulated beings would just be philosophical zombies. They'd act conscious but have no inner life, no subjective experience. And that were the case, the argument that we are likely simulated would lose its entire force because it's trying to explain our own conscious experience, which we know is rich with qualia.
Right. We know we're not zombies, or we think we do.
Exactly. So the hypothesis doesn't actually solve the mystery of qualia. It instead presupposes a computationalist solution. It takes for granted that consciousness can be programs or effectively emulated just by complex information processing. And this is a significant philosophical leap, isn't it? It's a foundational element that is itself still hotly debated and completely unproven. I mean, to grasp just how radical this leap is, consider that the simulation hypothesis essentially assumes that if you just write the right kind of incredibly complex code, consciousness will simply emerge from it. But this is precisely what the hard problem questions. Is consciousness merely an output of complex computation? Or is there something fundamentally irreducible, non-computational, about subjective experience? Many philosophers would argue that this computationalist solution is exactly what needs to be proven, not just taken for granted as a starting point for the simulation argument.
Okay, so let's follow this line of thought. If our universe is a computation, right, an immensely sophisticated simulation running on some kind of supercomputer in a base reality, could it bear detectable signatures? Could there be subtle clues hidden in the fabric of reality pointing to its artificial nature? This is where this sort of detective work begins, and it's truly where things get fascinating, I think. Proponents of the simulation hypothesis suggest we might actually find empirical evidence of its artificiality within our own physical laws. And the most direct, the most compelling parallel to ancient atomism here is this idea of a finite resolution. The idea that much like a digital image, our reality might actually be pixelated at its most fundamental level. Not infinitely smooth, but chunky.
Indeed. A simulation running on finite computational resources, and any actual simulation must, by definition, be running on something finite. It simply cannot be infinitely continuous. It can't have infinite detail. It must, by logical necessity, be discrete at some fundamental level. It has to be composed of minimal indivisible units of space, time, and information. These would be analogous roughly to the pixels on a digital screen, or maybe voxels in a 3D simulation. The Planck length, which is incredibly tiny, about 1.6 by 1035 meters, and Planck time, equally tiny, about 5.4 by 1044 seconds. These are often suggested as candidates for this fundamental pixel or voxel of spacetime, the smallest possible increment. Some theoretical physicists have even proposed experiments, like looking for anomalies in the distribution or behavior of ultra-high-energy cosmic rays. The idea is that these might be potential empirical evidence of this underlying grid-like structure of spacetime. Imagine like a cosmic ray hitting the edge of a simulation pixel, and the subtle computational limits causing a tiny deviation from the physics we'd normally expect. It's a really intriguing line of investigation, sort of seeking glitches in the cosmic matrix, you might say.
And the potential clues, they don't stop there. Some of the most counterintuitive, most mind-bending phenomena in quantum mechanics, which is, the very bedrock of our understanding of the universe at small scales, are interpreted by some people as indirect evidence for a simulated reality. Take the observer effect, for instance. This is the idea where a quantum system state is kind of probabilistic, fuzzy, undefined, until it's actually measured or observed. Then it snaps into a definite state.
Mookie.
Right. This is often likened to how a video game engine works. It only renders a detailed environment when a player actually looks at it or when their avatar approaches a certain area. Why waste precious computational resources rendering stuff that's not currently being observed? It seemed like a highly efficient way to manage a really complex simulated world. Saves processing power. Then you have quantum entanglement. That's where two particles become linked in such a way that they instantaneously share the same fate or correlated fates, no matter how vast the distance separating them. Einstein called it spooky action at a distance.
Didn't like it much.
He really didn't. But simulation proponents compare this to object-oriented programming, where changing a variable in one part of the code can instantly update its connected counterpart somewhere else in the program without needing to send a physical signal across space. It's just linked in the code. Even wave-particle duality, where fundamental entities like electrons sometimes act like waves, sometimes like particles, is seen as analogous to, say, a pixel being both a discrete point on a grid and part of a continuous wave-like image, depending on how you interact with it or observe it. Now, these aren't definitive proofs, obviously, not even close, but they offer these intriguing lenses through which you could view our strange quantum reality as potentially being optimized by computational rules, like a clever simulation designer might do. All right, let's move into segment 3, the atom and the pixel. We need to critically assess this central analogy.
Yeah, this is where we really need to dig in, I think. The most profound, I'd say genuinely legitimate, connection between ancient atomism and the modern simulation hypothesis. It really does lie in their shared commitment to a discrete ontology. That's their fundamental point of agreement. Both theories fundamentally reject the infinite divisibility of reality, whether we're talking matter or space-time. Instead, both posit a bottom level, a fundamental unit beyond which division simply cannot proceed. For Democritus, as we discussed, it was the atomon, the physically smallest uncuttable piece of matter, and he introduced it explicitly to resolve Zeno's paradoxes about infinite divisibility, to make motion possible. For the modern simulation theorist, it's the pixel, or the Planck scale unit, the smallest possible increment of space-time or information. And this is necessitated not so much by logic, but by the practical assumption of finite computational resources. You can't compute infinity.
So this shared structural feature, this idea of a granular, non-continuous reality, it's a powerful and enduring response to the logical problems posed by the concept of the continuum, especially those paradoxes Zeno highlighted so brilliantly.
That's a really excellent summary of their core conceptual similarity. It really helps to see how structured their approaches are, even though they're millennia apart. And to really crystallize this, let's maybe look at a quick side-by-side comparison, drawing from the analysis in our source material. Think of it like this. Fundamental constituents. Okay, ancient atomism. You've got atoms, indivisible matter, and the void, empty nothingness, simulation hypothesis. You've got information, code debits, and the substrate, the underlying computer. Different stuff.
Very different, yeah.
Nature of reality. Atomism sees reality as fundamentally objective, material, totally independent of observers. The simulation hypothesis sees it as computational, informational, and possibly observer-dependent, especially with that rendering on demand idea we talked about. Smallest unit. For the ancients, it's the atomon, a physically indivisible particle with intrinsic shape and size. For the modern theory, it's the pixel or Planck unit, a discrete unit of space-time info lacking its own intrinsic properties. It just holds data.
Key difference there.
Nature of space. Atomism had an infinite, empty, passive void, the keenon, as the stage for atoms. Simulation theory suggests a finite or maybe infinite computational grid, which isn't just passive, it's an active, structured part of the simulation's architecture. Explanation for change. Atomism explains change through mechanistic causality, just atoms colliding and rearranging. The modern view uses algorithmic progression, the simulation's code executing over discrete time steps. Status of qualities. Democritus famously said qualities exist by convention. No, they're just subjective effects of atomic shapes on our senses. In simulation theory, qualities, qualia, are typically seen as emergent properties of computation, a presupposed feature of a high-fidelity simulation designed to mimic consciousness.
Still presupposed, not explained.
Exactly. Determinism. Atomism was strictly deterministic based on necessary atomic collisions. The simulation hypothesis is also potentially deterministic, based on its code, but it could easily include programmed randomness or pseudo-randomness to mimic quantum uncertainty. Core motivation. Atomism was really developed to solve the Eleatic paradoxes of change and motion, giving a coherent physical story. The simulation hypothesis is more about addressing the probabilistic implications of future tech, like what happens if we can simulate universes, key unexplained. For atomism, it was the ultimate origin of atoms and their motion, the first cause problem. For the simulation hypothesis, it's the nature of the base reality or substrate running it all, which leads straight to that infinite regress problem. When you lay it out like that, they really do look remarkably similar in their structure, don't they? Attempting to answer fundamentally the same questions about the ultimate nature of existence, despite the huge gap in time and technology.
They do, structurally. But despite those powerful and really evident parallels, the analogy between Democritus's atom and a simulation's pixel, it truly begins to break down when you look closer. It reveals a fundamental, really an ontological shift in the very conception of reality itself. See, Democritus's atoms possessed intrinsic properties. They were conceived as real, physical objects with inherent, self-contained shapes, sizes, textures. Some were convex, others concave. Some had little hooks and barbs that directly dictated how they could interlock and interact. Their behavior was a direct, necessary consequence of their physical form. An atom was its properties, in a sense. A pixel, by contrast, is essentially a uniform, featureless placeholder. Its properties, things like color, brightness, or specific data values it represents, are entirely extrinsic. They're assigned and interpreted by an external program or algorithm. A pixel merely displays or stores these properties. It doesn't possess them inherently as part of its own nature. And this distinction between intrinsic and extrinsic attributes is absolutely crucial. One is an inherent property of the thing itself. The other is an assigned external attribute.
That is a critical distinction, yeah. Let's really unpack the metaphysical depth of that for a second. This difference between intrinsic and extrinsic properties, it leads us to a much deeper ontological chasm, a huge gap between the two theories. Atomism, fundamentally, is a theory of substance. It claims that reality is ultimately composed of tiny, solid, material things. The world, at its most basic, is made of stuff, physical bits.
Stuff, exactly.
The simulation hypothesis, however, isn't primarily a theory of substance. It's really a theory of information. It claims reality is fundamentally code, patterns, algorithms. And what we perceive as matter or stuff is just the output, the rendered appearance of that code's execution. That's a profound shift, isn't it? From asking what is it made of to asking what is the underlying logic or program. It's really the difference between seeing the universe as a giant collection of Lego bricks versus seeing it as an incredibly sophisticated computer program running, a totally different kind of reality.
Precisely. And furthermore, even if we set aside the intrinsic-extrinsic debate for a moment, the simple, hard-edged certainty of a digital pixel, a perfectly defined, quantifiable unit, is actually a pretty poor analogy for the fundamental constituents of our physical world, at least as described by modern science. Quantum mechanics, which probes the smallest scales of reality, reveals a universe that is inherently probabilistic and, fuzzy. It's far from the crisp, definite state of a pixel. The Heisenberg uncertainty principle, for example, imposes a fundamental limit on how precisely certain pairs of properties, like position and momentum, can be simultaneously known for a particle. This suggests the kind of built-in indeterminacy, a fundamental fuzziness at the heart of reality that is conceptually quite alien to a simple deterministic grid of pixels. It's not just a matter of resolution that could, theoretically be improved with more computing power. It seems to be a matter of the very nature of reality at that fundamental level being less defined, less certain than a pixel. A pixel is usually either on or off, or holds a definite value like red or blue.
A quantum particle, before measurement, exists in this weird superposition of multiple states at once. That's a far more complex and indeterminate kind of reality.
Okay, so given these really crucial distinctions, what does this all mean for how we should understand that popular pixel analogy? The comparison between ancient atoms and modern pixels, especially drawing from video games, seems like it's mainly a pedagogical tool, right? A heuristic device.
That's a good way to put it, yeah.
It's like a useful ladder to help introduce this abstract concept of a computationally defined discrete reality to a modern audience. It leverages a technology people readily understand, helps us visualize it. But for rigorous philosophical and scientific analysis, we probably need to be very careful not to take that ladder too literally. We need to, as the saying goes, kick that ladder away once we've used it to climb up. Sophisticated proponents of the simulation hypothesis, they ground their arguments in complex information theory, in the principle of substrate independence, and in these subtle interpretations of quantum mechanics, not just in literal pixelated screens. So the analogy is maybe a helpful starting point, but it can also seriously mislead if we take it too literally, and it might obscure these deep conceptual differences we've been discussing. Okay, now let's shift to another common argument people use for the simulation hypothesis, and this is where it gets really compelling for a lot of people, especially maybe those in tech circles. It's this inductive extrapolation argument, popularized by figures like Elon Musk. The argument basically goes like this: look at our simulations, like video games. They've progressed from really simple, blocky abstractions, think Pong, to astonishingly near photorealistic experiences in just a few short decades.
Incredible progress, undeniable.
Right. So surely this exponential trend will just continue. Eventually, simulations will become utterly indistinguishable from base reality itself. And the argument concludes, if it's possible for advanced civilizations to create such simulations, then it will inevitably be done. Someone will do it. And given the sheer potential number of simulations compared to base realities, it's statistically probable, maybe overwhelmingly probable, that we are living in one right now. It's a very intuitive, almost seems like an undeniable line of thinking for many people, just based on observing our own technological progress.
It is intuitive, I grant you that. But this line of reasoning, while appealing, it harbors a significant flaw. It's actually a fairly weak induction, philosophically speaking. Firstly, it just presumes that technological progress, things like Moore's law doubling computing power, can continue indefinitely without ever hitting fundamental physical limits. But that presumption isn't guaranteed at all. In fact, most growth processes, including technological ones, they tend to follow a typical S-curve trajectory. You get rapid advancement initially, but then it eventually plateaus as physical limits or diminishing returns are inevitably reached. We're arguably already seeing some of those limits emerging with silicon-based computing, for example. But maybe more fundamentally, it just assumes that the laws of physics and the base reality, wherever that is, would even permit the necessary computational resources. We're talking about the sheer energy, the information storage, the processing power required to simulate an entire universe down to the quantum level. Many physicists actually argue that simulating a universe with our level of complexity would likely require a computer vastly larger and more powerful than the universe itself, which makes it computationally intractable, maybe impossible, within our current understanding of physics. So this raises an important question for you to think about. Are we perhaps too quick to extrapolate from our own, possibly brief, technological trajectory? Are we doing that without adequately considering the potential physical constraints of reality itself? Or maybe the fundamental laws of physics that might govern any reality, simulated or not?
Yeah, good point. And to add another twist to that, the cosmologist Sean Carroll, and others too, have pointed out that this inductive argument, it contains a potential internal contradiction. It hinges, as you said earlier, on the assumption that we are typical observers, meaning our observations and experiences are broadly representative of conscious observers across the universe and across time.
The principle of mediocrity, basically.
Right. Yet, if we are truly typical, then our current inability to run such high-fidelity conscious simulations ourselves, well, that would strongly suggest that they are not, in fact, canon within the universe's overall history or future. If future civilizations are supposed to be regularly running trillions of these things, and we are indeed typical observers somewhere in that cosmic history, why aren't we running them now? Or why haven't we detected any evidence of them being run by others? It seems to undercut the very probabilistic foundation of the argument. It's a really clever philosophical twist, I think, that puts a significant dent in that simple inductive reasoning. Basically asks why our own present state doesn't seem to align with the predicted future state that the argument relies on. All right, segment 4. Let's bring some ancient critiques into this digital world and use them to test the simulation hypothesis.
Yeah, this is fascinating. The philosophical critiques that were originally leveled against ancient atomism, particularly by its most formidable intellectual opponent, Aristotle, they demonstrate this remarkable and, frankly, enduring relevance to the modern simulation hypothesis. It's quite striking. Aristotle's primary objection to Democritus, as we touched on earlier, was that his purely mechanistic metaphysics, just atoms bumping around, ultimately failed to adequately account for the reality of qualities, reducing things like color, taste, and sound to mere arrangements and interactions of colorless, tasteless atoms. It just seemed to explain them away rather than truly explain their intrinsic nature. He felt something crucial was lost. And this very same critique, it applies with striking force, I think, to the simulation hypothesis today. How can purely quantitative formal processes, lines of code, algorithms, numerical data churning away, how can they genuinely generate the rich, qualitative, subjective reality of conscious experience, our inner qualia? The hypothesis is reliance on substrate independence, as we discussed. It doesn't solve this fundamental problem.
It merely assumes a computationalist solution to the hard problem of consciousness. It basically takes for granted that consciousness can be programmed or accurately emulated. And this is arguably its greatest philosophical weakness because it sidesteps the very mystery it really needs to account for if it's going to be truly compelling. It essentially presupposes the answer to maybe the most difficult question in all of philosophy of mind.
That is a powerful and really direct parallel, isn't it? It shows how deep these philosophical roots run. Let's delve deeper into another of Aristotle's insightful criticisms. He also faulted Democritus for failing to provide an ultimate, kind of self-sufficient explanation for the very existence and the initial motion of atoms themselves. Where did they come from? Why are they moving?
Yeah, the prime mover issue, essentially.
Right. The atoms were essentially just posited as eternal, uncaused brute facts. They were just there, moving. No further explanation given. And this critique is perfectly mirrored almost exactly in the infinite regress problem that continually plagues the simulation hypothesis. If our universe is indeed a simulation, it logically requires a computer to run it, right? And that computer must be situated within some base reality. Okay, but then what about that reality? What are its fundamental laws? How did it come to be? And crucially, what's to stop it from also being a simulation, running on an even bigger computer and yet another, even more fundamental reality?
Turtles all the way down, or simulations all the way down.
Exactly. It leads to this unending, ultimately unsatisfactory chain of simulations all the way down, as you say. It fails to provide any final, grounding explanation for existence. The hypothesis doesn't actually solve the problem of the ultimate first cause. It just displaces it one level up the ontological hierarchy, leaving the most fundamental origins still unaddressed and potentially infinitely deferred.
Aristotle also, quite brilliantly, pinpointed a logical tension within the very concept of a physically indivisible atom that nonetheless possessed magnitude and shape. This is subtle, but important. He argued that if an atom has extension, if it has, say, a left side and a right side, or any discernible dimensions at all, then it must, at least conceptually or mathematically, be divisible, even if you can't physically cut it. If it has parts in thought, it's not truly simple. And this subtle critique can be repurposed with fascinating insight for simulation theory today. How does the abstract mathematical reality of the underlying code, which is purely informational, purely formal, how does that translate into the concrete, spatially extended, and dynamically interacting physical reality we vividly experience every day? The hypothesis offers no clear, detailed mechanism for this rendering process. There's a kind of magical leap assumed between the code and the world. It leaves this critical conceptual gap between the informational substrate and the actual perceived, seemingly physical world. It implies a fundamental discontinuity. And this raises another important question for us.
Can mathematics or information alone truly define and constitute physical reality? Or is there an irreducible gap between the abstract representation and the experienced tangible reality that needs some further non-computational explanation?
Okay, now remember Zeno and his infuriating paradoxes of motion, like Achilles and the tortoise. Those paradoxes highlighted the problems of infinite divisibility if you assume reality is continuous. Now, both atomism and the simulation hypothesis, in their essence, they adopt a discrete ontology, a granular reality, precisely to solve those paradoxes of the continuum. That was a key motivation. But here's where it truly gets interesting, because Zeno, being the brilliant and relentless philosophical provocateur he was, actually formulated other paradoxes specifically designed to attack discrete models of space and time. He had arguments against both sides.
Covered all his bases, didn't he?
He really did. His famous arrow paradox, for instance. It argues that at any single indivisible instant of time, which you could think of as analogous to a single frame in a digital simulation, a moving arrow is, for that precise instant, not actually moving. It occupies a space exactly equal to itself and is, for that fleeting, frozen moment, at rest. So if time is simply a series of these static frozen instants, how does motion arise at all? How do you get continuous flow from just a series of static snapshots? It seems like it should just be a series of frozen moments, not fluid movement. There seems to be a critical logical gap there too.
Yeah, this ancient puzzle poses a really serious and direct challenge to any pixelated or discrete model of reality, including the simulation hypothesis. If a simulation proceeds in discrete time steps, much like the refresh rate of a monitor or the frames per second in a video game, what exactly happens between those steps? Where does the motion happen? How is the subjective experience of smooth, continuous motion genuinely generated from what is fundamentally just a series of static states? If an arrow is truly at rest at every single indivisible instant, then by what mechanism does it ever actually get from point A to point B? It seems logically impossible. This really reveals that adopting a discrete ontology isn't some magical panacea that solves all paradoxes. It solves some, maybe creates others. In resolving the problems of infinite divisibility that troubled Parmenides and fueled Zeno's arguments against continuity, the simulation hypothesis may inadvertently fall victim to the more subtle but equally potent paradoxes of discrete composition. Zeno's arguments, when you take them all together, they form this comprehensive and quite devastating dilemma. Whether reality is ultimately continuous or discrete, our basic common-sense understanding of motion appears, through rigorous logical analysis, to be fundamentally incoherent. The simulation hypothesis, far from definitively solving Zeno, may simply find itself impaled on the other horn of his ancient and perhaps unavoidable philosophical dilemma.
That's a truly profound observation, and it really highlights how timeless these fundamental philosophical challenges actually are. It becomes pretty clear when you look at it this way that many contemporary scientific and philosophical objections to the simulation hypothesis are, in fact, kind of modern reformulations, new expressions of these very ancient problems. For instance, that argument we mentioned earlier, that simulating our universe down to the quantum level would require a computer larger and more powerful than the universe itself.
The resource problem.
Right. That's essentially a resource-based 21st century version of the ancient problem of composition. It asks, how can the parts adequately and efficiently constitute the impossibly complex whole without demanding an external system that is even more complex and resource-intensive? It's a perennial question, really, about the feasibility of building a specific kind of reality out of smaller components, whether those components are atoms or bits of information.
Exactly. And similarly, the common critique that the simulation hypothesis is fundamentally unfalsifiable. The idea that any evidence ostensibly against it, like finding a glitch in reality, could simply be explained away as just a programmed feature of the simulation itself. This echoes the somewhat non-empirical, rationalistic character of early atomism. Both theories, in their different ways, they risk becoming these kind of closed metaphysical systems. They postulate unobservable entities and structures based primarily on logical argument and internal coherence, rather than being easily subject to empirical testability. And this makes them inherently difficult, maybe even impossible, to definitively prove or disprove scientifically. They operate somewhat outside of normal scientific refutation. And finally, that ultimate nagging mystery of the simulation hypothesis, that intractable problem of the nature of the base reality that supposedly runs it all. Its substrate, its fundamental laws, its own origin. This is clearly the modern equivalent of the ancient philosophical demand for an ultimate explanation of the physis, the underlying nature of the atoms themselves. Where do they come from? Both theories posit a fundamental, foundational layer of reality, but both ultimately struggle to fully account for its properties and its origin. And this truly raises an important, maybe humbling question for us to ponder. Are we, as human beings, as philosophers, forever bound to question the very foundation of our existence? Or are there perhaps inherent limits to what philosophy or even science can ultimately explain about the first cause or the ultimate ground of being? Maybe some questions are just beyond our grasp.
Okay, let's try to wrap this up. Conclusion. 2 ontologies, 1 unknowable substrate. So, after this incredible journey, spanning millennia of thought, what does this all truly mean for our understanding? Where do we land? Well, the conceptual lineage connecting ancient atomism to the modern simulation hypothesis, it seems both legitimate and profoundly resonant. It's rooted in that shared commitment to a discrete, a granular reality. That core idea persists. Both of these intellectual frameworks, ancient and modern, represent these really ambitious attempts to reconcile an unchanging fundamental substrate, whether it's atoms or code, with the manifest change, the complexity, the undeniable dynamism of the world we actually perceive. However, that popular analogy between the ancient atom and the modern pixel, while it's intuitively appealing, maybe even pedagogically useful, it's ultimately, as we've seen, a philosophically and physically weak heuristic. It doesn't quite hold up.
Doesn't capture the depth, yeah.
It masks, or at least risks masking, a far more significant ontological shift in the history of thought. A fundamental move from a reality ultimately composed of fundamental substance, the physical stuff of atoms, to one fundamentally composed of information, the code, the patterns, the algorithms of a computational reality. That's a huge difference in worldview.
Absolutely. And ultimately, I think the most powerful and enduring philosophical critiques that were initially leveled against ancient atomism, things like the deep problem of explaining qualitative experience from purely quantitative parts, the hard problem, the failure to adequately address the first cause and that looming threat of infinite regress, and those persistent paradoxes inherent in discrete motion that Zeno pointed out. These critiques are not only applicable, but they find renewed and I'd argue potent force when they're directed at the modern simulation hypothesis. The vocabulary has certainly evolved. We talk about computation instead of metaphysics, substrate instead of physis. But the core logical and explanatory challenges, they remain remarkably unchanged across these vast stretches of time. And they compel us, I think, as thinking beings, to continuously confront the very boundaries of human knowledge and critically examine the foundational assumptions that are embedded, often hidden in our most cherished concepts of reality, matter, consciousness, and causality. It forces that deeper reflection.
So here's something for you, our listener, to truly mull over as you go about your day. Maybe look at the word a little differently. If both atomism and the simulation hypothesis, despite their vast differences in time and technology, ultimately grapple with such similar, deep, fundamental questions, and if they face such comparable philosophical hurdles, does that perhaps suggest something profound about the questions themselves? Does it mean that these questions aren't merely flaws in these specific theories, but are maybe inherent to any attempt by the human mind to define ultimate reality? Are these concepts, atomism, simulation, not really definitive answers in themselves, but rather powerful and timeless engines for posing the deepest, most persistent philosophical questions we can ask? Questions of the very nature of existence itself. Just something to think about. Well, that brings us to the end of another, I hope, captivating exploration here on AI history of Western philosophy. We hope you've enjoyed this expansive journey through granular realities, both the ancient ones and the digital possibilities, and maybe found some new avenues for your own contemplation.
We truly love exploring these profound ideas with you all, and we sincerely hope that today's discussion sparks some new possibilities, some new questions for your own thought and inquiry. That's really the goal.
Absolutely. And if you found this discussion thought-provoking, maybe insightful, or perhaps just plain fascinating, please do consider liking this particular discussion, subscribing to AI History of Western Philosophy if you haven't already, and maybe leaving a comment to share your own reflections, your own theories. Are we atoms? Are we code? Something else entirely. Your engagement, it helps us immensely. It encourages us to continue exploring these profound and sometimes perplexing philosophical concepts. Until next time, keep questioning everything.